Good day everyone, we are group number 8 and we are here to talk about Ian Stewart's chapter number 8, Your Dice in God. So, in group number 8 we have yours truly. I am 3rd class Decadent Dalun Johnny Lizard and together with me is 3rd class Decadent Paragas SCR. To start with, we'd like to think we can know things for sure. We want to know who will win an election, whether the inflation rate will decline, and whether a suspect has definitely committed a crime. However, the odds are not in our favor. As they all say, life is fraught with uncertainty. In fact, the universe may be fundamentally imprecise, and humans are terrible at guessing. We're almost always wrong when asked to predict the outcome of a random event. Fortunately, there is still hope. As award-winning mathematician Ian Stewart explains, mathematics has provided us with some of the tools we need to better manage the uncertainty that pervades our lives throughout history. Forecasting, medical research, and determining how to win an election is a surprising and satisfying tour of what we can and cannot know. To start here in our presentation, we have Sir Albert Einstein. So with the question, do dice play God? So he believed that God does not play dice with the universe, that the world in which we live is governed by precise laws rather than change. The branch of mathematics popularly known as chaos theory clarifies the question through a new paradox. Precise laws will offer the appearance of randomness. So throughout history, humankind always have these questions in mind about probability and uncertainty. And over time, uncertainty is something that we cannot give a solution with. It is just somehow like playing a snake and ladder game. It is not really the dice that makes you win, or it's not really you who can predict the dice to tell you you'll win the game, but it is the dice who will actually do the thing for you to either win or lose. So we cannot really say that after you throw a dice, you'll get that certain number you would like for you to be able to climb on the ladder or to reach 100 first. So that is actually what we also call this probability. And that is something that is very uncertain and we cannot even predict if ever we get 1, 2, 3, 4, 5, or 6 from a dice. Next. So, talking about Albert Einstein, we also have here quantum mechanics and theory of relativity. So what are quantum mechanics and theory of relativity? So whilst most of the universe is deterministic and measurable, quantum mechanics says there's a world of tiny particles behind everything that's governed by total randomness. Theory of relativity, on the other hand, states that Albert Einstein's theory achieved public recognition. Most people interpreted it as saying that everything is relative, a comfortable philosophy that, for example, justifies the rich ignoring the poor on the grounds that others are yet poorer. So as I mentioned a while ago, life is fraught with uncertainty. But as Ian Stewart demonstrates in his fascinating new book, humanity is constantly striving to predict the future. Again, we're very uncertain about our future. From the challenges or changes of weather and climate forecasting to the frontiers of modern physics, Stewart brilliantly explores the exhilarating milestones and frustrating limits in our quest to map out the shape of things to come. An extraordinary overview of the difficulties of forecasting the universe based on chance. So, to expound that explanation from Ian Stewart, he believed in himself that it is really mathematics that we can consider as a bright tool for us to solve probability, for us to solve uncertainty. That is why over time, right after this question or this thing that lurks on the mind of Ian Stewart, that also taps the mind of other famous mathematicians and scientists to think, like, how can we make uncertain things be certain? And how can we predict things from happening? So from that on, a lot of mathematicians and scientists have worked hand in hand to give solution to this. And this is right after following the progress of what Ian Stewart has started. So go on to our next slide. We have chaos theory. So we should also have to talk about chaos theory. So deterministic laws can produce behavior that appears random. Order can breed its own kind of chaos. The question is not so much whether God plays dice, but how God plays the dice. It is this discovery that has given us a science of chaos, and its implications have yet to make the full impact on our scientific thinking. So as I mentioned a while ago, we are playing on a dice. It is not really the dice, or it is us on how we play the dice that will make us win, or will let us achieve things we wanted to achieve. So still, it is under uncertainty of how the dice will be tossed, or how the dice, or what the dice will offer, will give you. Going to the next slide. So deterministic chaos has its own laws and inspires new experimental techniques. There is no shortage of irregularities in nature, and some of them may be manifestations of chaos. Turbulent flow of fluids, reversals of the Earth's magnetic field, irregularities in heartbeat, the convection patterns of liquid helium, the tumbling of celestial bodies, and etc. The bouncing of a billiard ball, the collision of atoms in gas, the underlying uncertainty in quantum mechanics. So these are quoted in the book as a few of the problems to which the mathematics of chaos has been applied. So now, the scientific view of chance. So first, determinism dominated scientific thinking for centuries. Second, every event or action is an inevitable result of preceding events and actions. And third, Sir Isaac Newton helped establish it at the core of modern science. So again, we have here Sir Albert Einstein and Sir Isaac Newton. So changing scientific view of chance. So Albert Einstein said that the notion of chance in nature, God does not play the dice. Again, God does not play the dice. Niels Bohr responded, on the other hand, stop telling God what to do. Next, again, going back to quantum mechanics, this superseded classical theory of mechanics, which includes quantum theory works well at atomic level, and second, classical works well enough to use in many applications above the atomic level, and is much easier and more intuitive than quantum theory. So presently, there is no unified theory of problems handling all gravitational forces. So as you can see on our examples, those examples really have uncertain results. We are still uncertain about answers of these specific examples, which is our topic is all about. It is all about uncertainty. It's all about dealing with probabilities and questioning what will be the probable outcome in the future. So we keep on mentioning a while ago about deterministic. So what do we mean by deterministic or deterministic system? So knowing the exact state of the system at some time gives the ability to predict the state at any other time. One ambition in mechanics is to describe or to predict how the universe evolves over the course of time, from the movement of the planets to the movement of atomic parts. We also have stochastic system, which deals saying that even if the exact state of the system is known at some point in time, its future state cannot be predicted, so not deterministic. So stochasticity is manifest in varying degrees, which includes approximate predictability with minor overlay of randomness, negligible predictability governed by chance. So now, let's vary determinism and chance. So, there is a question here, can determinism and chance coexist? So, can they live together? So, there is a dividing line between deterministic and stochastic processes, but it is a bit fuzzy. Deterministic, it is possible to know the exact location of the moon, while stochastic is the overcome of a coin flip random. So still determinism versus chance. Can a deterministic system be unpredictable? So how can the initial state be known exactly unless it can be measured with infinite precision? So initial state can be thought of as random with a certain probability distribution. Any future state will also be random with a different probability distribution, which can be deduced deterministically using the laws of mechanics. Systems like this, which behave unpredictably, are said to exhibit deterministic chaos. So, going back, God does play dice. So we have the question a while ago, do dice play God? But we have here, God does play the dice. God built uncertainty into the world around us in many amazing ways. What seems like uncertainty to us, or what seems like uncertain to us, is in fact certain to God. So there might be things we think are imprecise. There might be things that we still have to question. Keep on lurking on our minds about whatever specific things. But again, with God, everything is certain. So to end our report, so here is how we will summarize it. So uncertainty is present everywhere. Like whether you are in the school, in your home, on the mall, in the church, everywhere. Uncertainty is everywhere. It lurks in every future consideration, the weather, the economy, the sex of an unborn child, even quantities we think we know, such as population, contain the possibility of error. There's always an error when dealing about probability. There might be a lot of uncertain things, and there might be instances that we can, correctly predict or correctly identify specific things out of those uncertainties, but always take into consideration that everything has an error. So it's no surprise that throughout history, we've tried to create rigidly defined areas of uncertainty. We prefer a surprise party to a surprise asteroid. We started our search for uncertainty in an uncertain world by reading omens and livers, tea leaves in the stars. So that is how our ancient people do it. However, driven by curiosity, competition, and a desire to be better gamblers, pioneering mathematicians and scientists began to reduce wild uncertainties to tame probability distribution and statistical inferences over the centuries. Even us, the unknown unknowns, become known unknowns. Our pessimism led us to believe that some issues were insurmountable, and our intuition misled us. Worse, as we became more aware of the pervasiveness and diversity of uncertainty, we encountered chaos, quantum mechanics, and the limits of our predictive power. Throughout the course of this debate, one thing has become clear. Throughout this, do dice play God, one thing has only been clear. A reasonable probability is the only certainty. So that ends up our report for group number 8. Thank you and good day.